Hello, my name is Matthew Streeter. I am a soil scientist with the University of Iowa, and I am here today installing a new conservation practice called a modified blind inlet in Scott County. We are just north of Walcott, northeast of the big I-80 truck stop on Mike Paustian's farm. And we have worked with Mike a lot in the past on conservation practices. He's an awesome landowner to work with, and we are excited to be working on this new practice. It's a modified blind inlet. So what we are doing is we are replacing a standard orange tile inlet intake. We're going to remove that intake, and we're going to put in essentially a French drain or a blind inlet where we can farm directly over that. We remove all of the anything that's going to be above ground surface. And we're also going to add a bioreactor into the bottom of this pit. So in a typical French drain situation where we're removing the tile inlet, it's just a hole that's full of rock, and it acts as a sediment filter for water to move through. We trap those sediments, and then we allow the water to move through the tile. In this case, below that rock, we have about a foot or a foot and a half of wood chips, and those are acting to denitrify as water moves into this system. So during a typical rain event where we get runoff that occurs, runoff is going to move over this modified blind inlet. We're still going to trap soils and sediments in this rock filter. We're going to be trapping phosphorus in that rock filter as well. And then as that wood chip gets saturated during a normal rain event, we start the denitrification process. So those anaerobic microbes start to work, and we start losing that nitrate before it goes out of the system. So we've worked on these modified blind inlets before. We had a previous study with the NRCS with a Conservation Innovation Grant, and during that study that happened from 2019 to 2021, we were able to measure about a 40% reduction in nitrate concentrations through the use of this practice, which is really great considering they're pretty cheap to install, and if we were putting these in for a farmer, they could go in just a couple of hours. What we weren't able to measure through that study was load reduction. So we didn't have flow actually moving through the tiles. We didn't have a good idea about how much water and how much surface runoff was actually happening. So what we're doing with this study specifically, and the reason that we're incorporating the Agri Drain boxes, is so that we can measure flow. We're going to have precipitation, so we'll have rain gauges. We'll know how much rain is happening. We'll know how much runoff we're getting. We'll know how much water is actually moving through this modified blind inlet, and we will be able to estimate total kilograms of nitrogen being removed from this practice. Now, the practice that we're installing right here is behind a typical graded terrace. It's a farmable terrace, but these can be installed behind wascobs or behind any other kind of a contour terrace structure, or really in any kind of a situation where you have a standing tile inlet. These things can be used. So in terms of installation, if a farmer were to install a modified blind inlet, it would be as easy as getting a backhoe, digging a small trench. We have the help to determine how large that trench needs to be compared to the watershed area. But it's as easy as digging a small trench where your standard tile inlet is, and then putting some perforated tile in the bottom and then backfilling that with wood chips and P-rock. Now for our study, it's a little bit more elaborate than that because you can see that we have this Agri Drain control structure in the background, and you can see that we're starting to wrap up our installation. So we have that trench dug, we have the wood chips in the bottom, we have about half of the P-rock backfilled. Now the guys in the background now are finishing their calibrations on the radar sensor for the flow, and once they're finished with that, we can go ahead and finish topping off that trench full of P-rock. And I will say that as far as a lifespan is concerned, we have some of these that are up to a decade old now, and our recent study, our blind inlets from there are about 3 years old. We did have to top some of those off with a little bit of P-rock. We had a little bit of subsidence, but we're still seeing the same nitrate concentration reductions in that decades old site as we are in the site that's only 2 and 3 years old.
Hi, I'm Dr. Andy Craig. I'm here with Ecosystem Services Exchange and Agri Drain Corporation. We're installing a smart drainage system from Agri Drain here on a modified blind inlet where The blind inlet is got a little bit of a hybrid feature that it has wood chips underneath the layer of P-rock, so it can treat and denitrify that water that's draining in from the surface. The purpose of this structure here is to monitor the water level in the structure and also the flow rate of the treated water leaving the structure. So researchers can get the nitrate concentration and the flow rate, and then use that to calculate the mass load rate and reductions from the practice. So this smart drainage system is on the cloud on agridrainsmartdrainagesystem.com, and the researchers will be able to access that data real time, download the data, and manipulate it that way for post-processing. It's a plug-and-play unit. We basically just put in the posts in the enclosure. It's already programmed. We use a radar level sensor to monitor the water level, and then set equations from the lab to calculate the flow rate when that water spills over the weir. So what we're looking at over here is a 2-chamber control structure with basically, that's the box sticking out of the ground. Water flows into it, has to build up a little bit and then flow over a weir, and that's what where we calculate the flow rate. There's a radar sensor and a stilling tube that looks down at the water surface and very accurately and precisely tells us where that water level is. It allows us to calculate the head on the weir and the flow rate. And then the enclosure has a little programmable controller in it that does some math and algorithms and then sends data to the cloud to the Smart Drainage System website.
So the original modified blind inlet was referred to as an alternative tile intake, and this was this first project with the NRCS. And that team on that project was Thanos Papanucolo and Chris Wilson at the University of Iowa, as well as my counterpart, also my boss, the state geologist, Keith Schilling at the University of Iowa. And so Keith and myself and Thanos and Chris, we had this 3-year project to work on this, and we got these concentration estimates from these alternative tile intakes. I think that this spurred a lot of interest with the Nutrient Research Center, and they had a call for proposals that specifically was asking for more information about these. And now in this call, they're referred to as modified blind inlets, so it's a little bit synonymous. So Thanos and Chris have moved on. Keith is still an active part of the process, not here today, but he is here as well. But there's still a new practice. We have 3 of these installed previously from the past project, and now we're adding 2 additional ones. So I think there's 5 of these that I know of in the state. And then after this 2-year project, we should be able to get this listed in the nutrient reduction strategy, and hopefully we'll see a lot more of them going in.
My name's Mike Paustian, and I'm a 6th-generation farmer here in Scott County. Farm with my family. We raise hogs, corn, and soybeans, and we're in one of our fields today at an installation project for a blind tile inlet. So the reason we were interested in this project is I'm intrigued by the idea that we could treat the water in our field as it's going out our tile inlets, because that, there's a concern there that we're bypassing a lot of the natural filtering ability in the soil and just sending it straight out the tile line. And so this is one way that we could potentially treat some of that water, but at the same time I'm intrigued by the idea that this could be something we could adopt on other fields and eliminate some of our tile risers and just farm right through those areas. So not only would we be able to treat the water going out of the field, but it actually might make our lives easier by not having to farm around standpipes, which can be a hassle sometimes. So we're excited to try this out and be able to have some monitoring equipment in place so that we know exactly what's going on, and that way when another farmer asks me about this and wants to know if it works, I'll be able to say definitely yes or definitely no. So that's why I like to partner with groups to do some studies in our fields, because I have the same questions everybody else does, and if we can get some data to help us answer those questions and know what's effective and what's not, then I think that's going to help us be better stewards and make better decisions about what we do on our ground. I look at this as kind of an additional piece in what we're trying to do as far as protecting water quality, conserving soil, and things like that on our farm. So we've got a couple of saturated buffers in place, so that's kind of an edge of field practice that we're utilizing. And we've gotten to the point now where all of our acres are no-till with cover crops on there. So we're just trying to figure out what other things we can stack on top of each other to help us keep improving what we're doing as far as keeping our soil in place, keeping our nitrates, keeping our phosphorus in the field where it can be utilized by the crop, and just overall trying to be better stewards of what we're doing here on the farm. You know, from an energy efficiency standpoint, we've got a lot of hog facilities. Over the last several years, we've converted all of our hog facilities over to LED lighting. So that's kind of step one, is make sure we're reducing our energy usage as much as possible. But then in addition to that, then we've installed some solar panels on several of our sites. And the goal there is to, number one, it makes economic sense for us. It's kind of a hedge on energy prices. My experience in my lifetime has been energy prices never go down, they only go up. So we look at this as a way to kind of lock in energy prices to some degree, but also then it's helping us reduce our carbon footprint. And that's something we're looking at. It's something consumers are telling us is important to them. And some of the companies we do business with are telling us it's important to them. And so we're starting to look at getting a handle on, what exactly is our carbon footprint on our farm. And so we're working with a project that the National Pork Board is doing to actually take data from our farm and use that to actually figure out what the actual footprint is for what we're doing here on our farm. And so what we've seen so far is very encouraging, and I think that's going to be one way for us to kind of get a measurement of where we're at as a farm and what we might be able to do to get better. We're always tweaking things and trying to do better. So you can't see it yet because this field just got seeded with cover crop last week, but I mean, I'm literally standing on our next project right now. We've been doing cover crops for probably 7 or 8 years, but we're still tweaking and still trying to get it right. So just in this field here, we have some trials going on. We've done a lot of cereal rye cover crops in the past. This year, we've got some hairy vetch and crimson clover mixed in with some of that cereal rye on some fields. In this particular field, we've got another trial going where we're actually trying some winter camelina, which is a brassica, so it's something completely different. Just to try it and see if it works and how it compares with what we're used to, just to see what our other options might be. The hairy vetch and the crimson clover, we're trying to add some winter hardy legumes into the mix to maybe fix a little nitrogen for us to help the next crop out. So there's always something to tweak, and whether we're talking about soil and water conservation, whether we're talking about crop production, whether we're talking about our hogs, it's always about what can we do to get better every year. And so we're trying to do things every year to just make those incremental steps forward. And what we're doing here today is just kind of another one of those incremental steps on our path to just improving what we're doing. So yeah, my kids would be the 7th generation to be on the farm. As far as whether or not they're going to want to be farmers someday, I can't say for sure yet, but one of my biggest jobs is to make sure that the farm is in better shape if they want to farm than it was when I started. And so that's kind of in the back of my mind with all the decisions that we do. How can we make this farm better for future generations? So our oldest is actually a freshman at Iowa State in ag engineering, so some of this stuff might be right up his alley, and if he has interest, then hopefully I'll do a good job of making sure the farm's here for if him or either of my daughters are interested in farming. That's what it's all about, just making things better for the next generation.